Greetings everyone. This is our term project and we are going to present it today. The group partners with me for this project were Mr. Hamza Khalid, Mr. Daud Sameem and Ms. Ifat Alvi. Let's continue with the overview. As you know that this tool was regarded with network traffic classification, and there are many techniques which are being used these days to classify network packets. We listed out that techniques in our report, and we reviewed literature, especially Wireshark and other packet sniffers. Moreover, we used WinDump and Python for the development purpose, and PyQt and PySimple GUI for graphical user interface. Results were very satisfactory. Conclusion is that we succeeded in developing such a nice tool. Let's continue with the introduction. Computer networks has been grabbing the interest of many researchers in terms of solving complicated problems. One of those problems is internet traffic classification. Internet traffic classification regards with labeling or identifying the transferred data type over internet. Internet traffic refers to the data transferred over internet and the protocol via which the data is transferred. In computer networks, this data is identified with different names. The most frequent name of the data is packet. So this report aims to develop a tool which could identify those packets. There are different types of packets which include DNS packet type, voice over internet protocol, HTTP or HTTP secure, RTP and FTP. These packets are comprised of addresses, error detection, correction and hop limit. Moreover, there may be length, priority and payload. Payload is the data which is attached to the network header, and the payload is the real data which is transferred over the internet. But this gets encrypted in packet form, and as you know that TCP IP stack adds header on every layer. Furthermore, the correction and error detection is also dependent on the layers in TCP IP stack. DNS packet is shown, and its structure is elaborated as such that DNS packet contain a header, a question which is referred as query, and the answer which is referred as response, and an authority and additional section. Additional section of information contains ID, QR, opcode, AA, TC, RD, RA, RD, ZR code, QD count, AN count, NS count, AR count. Moreover, the question section is consisting of Q name, Q type, Q class, and the answer section is comprised of name type, class, TTL, RD length and R data. This was the structure of DNS packet, and DNS query is shown in the picture. Now let's move on DNS response. This is the DNS response, and it also has the same structure as discussed in the previous slide, and the next picture is showing HTTP header and its body. Now let me clear that there are many techniques to identify these packets. As you know that packet structure is different for every packet, and every packet is difficult enough to be identified, and therefore there are many techniques which include port based technique, host behavior technique, flow control technique, These are the techniques which are used to identify these packets and their classes and to analyze these packets. Those classes will be further discussed by Ms. Ifat Alvi.
We have used four approaches in our report. The first one is port-based approach. It is simple and fast. It uses internet assigned numbers authority standardized fixed port numbers to identify the class of packets. It reduces contingent complexities. Contingent complexities are caused by cases such that when dealing with port-to-port transmission techniques where there is no fixed port numbers available, and it uses port numbers of commonly used application, so it reduces the complexities. Now the second one is payload based approach. It identifies the application by matching the payload of packets and the character string associated with the application. It is reliable. it its disadvantage is that it has high cost and it is heavy load. It means that it limits the general use on high bandwidth links, and now many modern applications with encrypted payload leads to this technology in vain. It is also known as DPI, which stands for Deep Packet Inspection. The third approach used is host-based approach. It uses heuristics to perform classification. It uses algorithms that classify traffic by analyzing the profile of a host, that is the destination and the port of the host communications, and it determines which type of traffic it is. It captures behavioral information of the host to match it against the host behavior signatures of the application. An advantage of using host-based approach is that it classifies traffic even if it is encrypted. Its disadvantage is that it requires the number of flows specific to a particular type of traffic to reach a certain threshold before they can be classified. The last approach we used is flow feature based approach. It employs machine learning to find patterns in a packet. Now these methods include naive Bayes, K nearest neighbor, logistic regression, clustering algorithms, and support vector machine. It identifies packets on various statistical features of flow packets. Now these flow level features include flow duration, data volume, number of packets, and variance of these metrics among others. Its disadvantage is that it requires a large scale of dataset. Now time-bin programming is also used to find these approaches, and time bin is the time in which a packet is captured. The bits are encoded through polarization of photons. Time bin coding has been used to efficiently generate entanglement that is robust against PMD, that is polarization mode dispersion, and random chromatic dispersion over 50 km of standard fiber. So to remove the effect of decoherence and fluctuations, we use time bin encoding. In our literature view, we have found out that Wireshark is a similar tool like the one we have developed. It is free and open source. It analyzes the packets. It shows packet stats. It uses a Qt widget toolkit for interface and PCAP to capture packets. Now, it also has a terminal-based version called Tshark. It does the same work as TCP-dump, but it shows the data in graphical interface. Other packet sniffers include Cevius OmniPeak, Manage Engine, NetFlow Analyzer, Telerik Fiddler, and a Colasoft Caspa.
Assalamu alaikum. My name is Hamza Khalid, and I will be covering the methodology part of our project. So, first of all, packet sniffing. Yeah, there were basically two approaches to packet sniffing. There was one was passive packet sniffing, the other one was active packet sniffing. The portion of active packet sniffing is that it deals with switches, and it is the one that interferes with the flow of our network packets. Interferes with it. Passive packet sniffing, on the other hand, works for the hub devices, Ethernet hubs, and it does not interfere the network flow. Since our project environment is simple, so we'll be going with passive packet sniffing. Other one is the network packet analyzer, that how we'll be reading the packets that are at the moment coming at the network on our machine. For that, we'll be using WinDump, which is an alternate for TCP-dump for Linux. WinDump is an alternate for Windows. Since we'll be working on Windows, we'll be sticking with WinDump. And what WinDump does is actually that it captures the packets, presents them, and you can analyzes them, presents different information about them, which can be of importance or use to us. Moving on. These are basically the different commands that we will be using and dealing with. The basic commands -d, which will display list all the network interfaces at the moment on our machine, as you can see here. The other command, like -i, as you can see below, it states all the packets, live packets captured, presents the information you can see, and kind of gives the summary as well, how many packets were captured, energy by filter, and everything like that. Now, since we'll be no, this one command is here. I forgot to mention it. My -r is used to read the packets from, like, if you capture the packet, live captured packet before I save them in a file, I will read them again. The .pcap extension files you can also use WinDump for that purpose, as you can see here, and it states all the packets information that was stored in them. Since we'll be making our own package sniffer, and we're working on Python, we'll be using our basic Python libraries. Scapy library, one of the basic libraries. If we are dealing and we want to read information stored on a .pcap file, it will state all the pack information for us in a good format. The subprocess library is an important one because we will not be displaying our result on the basic command line. We have another debugger in our PyCharm that we'll be using. So in order to display the information to that, we will use a subprocess library. It will basically read the output being presented on the command line and redirect it, as it states here, to our graphical user interface, which I'll be showing you further. Moving on, yes, this is our basic interface. This is our main window. So here we can see we'll have all the devices that from which we can select and sniff the packets from. You can choose any one of them. It will display all of them available at that moment we are using it. And as I mentioned before, we can also read the back information which was stored on our file. In order to read that, and in order to display that, we have this interface. So if we read a packet from our .pcap file, it will be displayed here in this interface. And it will have basic information like what's the packet number, IP, destination IP, protocols, and other information like length and info. As you can see that from our results, we save a number of packets captured in a source file and in a .pcap file, and then we read that using the library I mentioned before, Scapy, and this is the result for it. The packet number, the source IP, destination IP, as you can see, and the protocol information is also there. This one I can mention before. That one was the one that we read from a file. This one is like in the case we were reading the packets and we were capturing the packets live packet capturing. This one is what's happening is reading the output being that a WinDump is capturing the packets, and our library I mentioned before, subnet library is redirecting those packets to our GUI from the command line to our GUI. So you can see the basic information of everything, what the IP address is, the acknowledgements, what data on it, everything in that case is presented here in our GUI. In conclusion, I can say that for all the basic requirements that we mentioned that we will achieve in our project, we pretty much achieved that. We provided a good interface, a simple interface, straight to the point. So that kind of interface can be helpful for beginners. That is easy to perceive. For our project, we have a successfully classified only port-based classifiable packets. The other part, the non-port-based packets, we didn't capture them. We didn't provide any mechanism for that. But since that wasn't our requirement, so this will work as well. Yes, for a good understanding, yes, we use simple libraries and a very basic, you can say, approach to it, so it can be helpful for beginners in that point as well. And our basic motive was to monitor and analyze network traffic, so it can serve that purpose, or it will serve that purpose. This isn't the end. You can say we tend to work more on our project. You can use different approaches, you can say intelligence approaches, neural networks, and other like approaches to make our system even more intelligent, to provide even better solutions, which is the goal here. So thank you, and we have a demo on our YouTube link, and if you have any further questions, please feel free to contact us. Thank you.